Every spray bottle you've ever bought, every chemical you've ever dusted across your tomatoes, every product that promised a pest-free garden and delivered a dead one, none of it was necessary. And the proof has been sitting in a hillbilly's woodpile and garden patch for 300 years. The old-timers in Appalachia didn't call it integrated pest management. They didn't call it anything at all. They just called it Tuesday. And their gardens were clean. Their yields were real. Their soil didn't turn to gray powder after 5 seasons. Somewhere between the 1940s and today, we traded a complete living system for a bottle of chemicals that the industry knew, we now have the documents to prove it, were born from the exact same research that produced sarin nerve gas. That's not a metaphor. That's the history they never put on the label. Picture a back hollow in the southern Appalachians, sometime in the 1920s. A woman, maybe someone's grandmother, maybe someone who never made it into any history book, walks the rows of her kitchen garden at first light. She stops at the garlic border she planted along the south edge. She pinches a clove between her fingers, crushes it, and smells it. Satisfied, she moves to the ash bucket hanging on the fence post and begins dusting the base of every cabbage plant with handfuls of fine gray powder from last night's fire. Then she kneels and tucks orange marigolds tighter into the rows between the tomatoes, pressing the soil around their roots. The whole thing takes 20 minutes. No spray rig, no protective gloves, no warning labels. And when the neighbors' gardens were overrun with aphids, cabbage worms, and soil nematodes that rotted their crops from underneath, hers were untouched. People called her methods old-fashioned. Some called them stupid. Here's the question the rest of this video will answer. What did she know that we've been paying an industry to make us forget? Before we get into it, I want to ask you something directly. Have you ever followed every instruction on a pesticide bottle, applied it exactly right, and still watched your garden get eaten alive the following week? Drop a yes or a no in the comments right now, because what you're about to discover will change how you see every product on that garden center shelf for the rest of your life. Walk into any garden center today and stand in front of the pest control aisle. Really look at it. Dozens of products, dozens of active ingredients, signal words like caution and warning and danger printed in red. Pick up one of the mainstream insecticide sprays and read the back. You'll find organophosphates, chemicals that work by shutting down the acetylcholinesterase enzyme in the insect's nervous system, jamming the signal between nerve and muscle until the creature convulses and dies. Effective, yes. But here's what the label doesn't tell you. Those organophosphate compounds were not designed for gardens. In 1936, a German chemist named Gerhard Schrader, working at IG Farben, synthesized a compound called tubin while trying to develop a new commercial pesticide. He had accidentally invented the world's first nerve agent. A few years later, he discovered sarin, the same acetylcholinesterase pathway, the same mechanism, the same target in the same nervous system. After World War II, American companies gained access to Schrader's research, and parathion and malathion became the first commercial organophosphate pesticides. By the early 1950s, DDT production had climbed to over 100 million pounds a year. The chemical era had arrived, not because it was the best solution for gardens, but because the factories and the intellectual property existed and needed a peacetime market. Here's where it gets worse. Before all of this, American farmers lost roughly 7% of their crops to pests. By the 1980s and the 1990s, with vastly more pesticide use than ever before, crop losses had risen to 13%. More chemicals, more money spent, more crops lost. And over 600 pest species have now evolved resistance because when you apply a single target poison repeatedly, you are running an involuntary breeding program for the survivors. Here is the part that should make you angry. The industry has known this treadmill exists. It is not a side effect of the system. It is a feature of the business model. A resistant pest requires a new product. A new product requires a new registration, a new patent, a new marketing campaign, and every time the cycle resets, you are told that the failure in your garden was your fault. Wrong timing, wrong dilution, wrong application method. You were given a product designed to keep you buying, not a system designed to keep your garden clean. And this is the important thing to understand. You are not a bad gardener. Your soil is not broken. Your plants are not unusually weak. You were handed a fundamentally inadequate tool and told it was the only one available. The woman with the wood fire ash and the garlic border and the marigold roots knew better, and so did everyone around her. Let's go layer by layer through what that old system actually was, because each piece of it has been studied, confirmed, and in some cases found to outperform the synthetic alternatives. The first layer is garlic spray. Folk gardeners across Appalachia and throughout rural Europe have used crushed garlic preparations for centuries. The recipe was simple: garlic steeped in mineral oil overnight, strained, diluted with water, and sometimes mixed with a thin bar of hand soap. What makes it work is a compound called allicin, which forms the moment garlic tissue is crushed. Allicin decomposes rapidly into secondary sulfur compounds, including diallyl disulfide and diallyl trisulfide, and those compounds do something remarkable. They inhibit acetylcholinesterase in insects, the same enzyme, the same pathway, the same mechanism as the organophosphate pesticides born from Schrader's nerve agent research. The difference is that allicin breaks down within days, leaves no soil residue, and insects cannot develop resistance to it because the plant rebuilds it constantly. Research published on garlic oil's fumigation toxicity against stored product pests has confirmed diallyl trisulfide as the most potent of these compounds. The garlic border was not superstition, it was applied chemistry. The second layer is wood ash. What it does to slugs and snails is almost poetic in its efficiency. Think of the ash bucket on that fence post. Wood ash carries a pH of 10 to 12, strongly alkaline. When a slug or snail crosses a barrier of it, two things happen simultaneously. The alkaline compounds cause direct chemical burns to their unprotected body tissue, and the potassium salts pull moisture out of their bodies through osmosis. A creature that is roughly 90% water does not survive this. A 2020 study published in the journal Applied Sciences tested ash from 7 different tree species against Spanish slugs. Oak and spruce ash caused the highest mortality. Combined barrier and dusting techniques left only 10% of plants damaged compared to untreated control plots. And wood ash does something else. Its high potassium content, absorbed through plant roots, thickens cell walls throughout the plant. Thicker cell walls are harder to penetrate. The ash wasn't just killing pests, it was building the plant's own immune system at the same time. The third layer is diatomaceous earth. This one is almost miraculous in its simplicity. Diatomaceous earth is the fossilized remains of microscopic algae called diatoms. Under magnification, each fragment looks like a disc with razor-sharp serrated edges. When an insect walks through it, those edges score through the waxy outer layer of the exoskeleton, the layer that prevents moisture loss. It then absorbs the cuticular lipids at up to 3 times its own weight, stripping the insect of its waterproofing entirely. Death by desiccation follows within 24 to 72 hours. The USDA found diatomaceous earth more effective than malathion against lesser grain borers, rice weevils, and confused flower beetles. And here is the critical advantage. Because it operates through purely physical abrasion, insects cannot develop resistance. There is no chemistry to adapt to. You cannot evolve around a razor blade by changing your enzyme production. Pests have no genetic response to being cut. The fourth layer is marigolds, and this is where the science becomes genuinely astonishing. Marigold roots, not the flowers, the roots, release a compound called alpha-terphenol. Researchers have described it as one of the most toxic naturally occurring substances ever identified. Under ultraviolet light, it acts as a singlet oxygen sensitizer, generating reactive oxygen species that penetrate nematode body walls and destroy them from the inside through oxidative stress. LC50, the concentration required to kill 50% of a target population, is 0.002 parts per million. To put that in perspective, that is a vanishingly small amount. Over 80 years of research confirms that marigold borders suppress soil nematodes as effectively as or better than chemical nematicides. A 2019 study at Newcastle University proved that French marigolds also repel whiteflies, with the volatile compound limonene doing the work. Researcher Niall Conboy noted that many experienced gardeners already knew marigolds worked. His team proved why. The fifth layer is companion planting, and this is where we need to talk about the Three Sisters. For at least 500 years before European contact, the Haudenosaunee Confederacy cultivated corn, beans, and squash together, not separately, not in rotation, but simultaneously in the same hill of soil. Academics dismissed it as cultural practice. Then, in 2024, a study published in Science Direct analyzed what the Three Sisters polyculture actually does to corn at a biochemical level. The results were clear. The polyculture increased defensive benzoxazinoid compounds and plant stress hormones in corn leaves, reducing Asian corn borer survival by nearly 39% and the larvae's relative growth rate by almost 73% compared to monoculture corn. The plants were not just sharing space, they were signaling each other. The squash leaves were producing volatile compounds that the corn was reading as a threat warning, triggering its own chemical defenses before any pest arrived. By the 1930s, forced assimilation policies had nearly erased this system from native communities. We lost centuries of agricultural intelligence in a single generation. If you are finding this valuable right now, and I believe you are, take a moment and hit the like button, because we are just getting to the part that explains why all of this was abandoned in the first place. So why did we walk away from a system that worked? 3 reasons, and they all come back to the same thing: speed. The old methods were slow. Garlic sprays needed to be made fresh. Ash needed to be collected, stored, and applied by hand after every rain. Companion planting required planting across an entire growing season. A barrel of DDT could be applied to thousands of acres from a crop duster in a single afternoon. Cost. Every element of the folk system required either skilled human labor or time, 2 things that industrial agriculture was designed to eliminate. Cheap synthetic chemicals made the math look straightforward. $1 spent on pesticides returned $3 to $5 in increased output, at least in the short term. Technology. The petrochemical infrastructure built during World War II needed to be repurposed. The factories existed. The chemists were employed. The organophosphate synthesis routes were documented, patented, and ready. When chemical companies looked at the American farm, they did not see a system in need of improvement. They saw a market that did not yet exist. The hidden cost arrived slowly. The soil did not notice for years. The bees did not start dying in numbers until the neonicotinoids arrived in the 1990s, a class of pesticides that, ironically, was designed by studying nicotine's structure. Nicotine is the active compound in tobacco water, one of the oldest folk insecticides in recorded history, documented since 1690. The industry took the molecule that grandmothers had been using, diluted in water, and synthesized a version that persists in soil for months, expresses in pollen, and now appears in 86% of American honey samples. Beekeepers today lose 40 to 60% of their hives annually. The timeline does not lie. These losses began their rise precisely when neonicotinoids replaced older methods at scale. Here is what you can actually do with this, starting today. There are 3 levels of commitment, and every one of them works. The first option is the simplest. Get diatomaceous earth. Not the pool-grade version, food-grade diatomaceous earth, which you can find at most farm supply stores, on Amazon, and increasingly at large hardware retailers. Look for bags labeled food grade or OMRI listed for organic use. Apply a ring of it around the base of any plant being attacked by crawling insects. Reapply after rain. That is it. No mixing, no dilution, no timing window. One tool, physical action, no resistance possible. The second option takes about 15 minutes of preparation. Make a garlic spray. Take a full head of garlic. Do not be shy and crush every clove. Soak the crushed garlic in 2 tablespoons of mineral oil for at least 24 hours. Strain it through a cloth into a clean jar. Mix 1 tablespoon of that garlic oil with 1 teaspoon of plain dish soap and 1 liter of water. Pour it into a spray bottle. Apply it to the upper and lower surfaces of leaves in early morning or late evening. Never in direct midday sun, which will burn foliage. Reapply every 5 to 7 days. This spray handles aphids, whiteflies, spider mites, and a range of soft-bodied insects. Make it fresh each week. The allicin degrades and fresh is always stronger. The third option is the most powerful and requires planning, but it costs almost nothing. Build your garden the way the old-timers built it. Plant marigolds, French marigolds specifically, as a border around every vegetable bed and as interplanting between rows. Let them grow all season. It takes several weeks for the root compounds to penetrate the surrounding soil deeply enough to suppress nematodes. Scatter wood ash around the base of brassicas, around lettuce, around anything slugs favor, especially after rain when the ground is moist and slugs are active. And if you grow corn, plant beans with it. Plant squash with it. The Three Sister system is not a novelty. It is a fully documented pest suppression and nitrogen fixation system that was feeding civilizations for 500 years before we had a single synthetic chemical to our name. The woman in that back hollow garden did not have a chemistry degree. She had something better. She had observation passed down through generations, tested season after season, refined by necessity, and confirmed by results. Modern science did not discover what she was doing. It caught up to her. The garlic border, the ash bucket, the marigold roots, the companion rows, each one is now documented in peer-reviewed journals, validated by university field trials, and in some cases found to outperform the synthetic alternatives that replace them. Reframe her one final time. She was not primitive. She was not backwards. She was an ecological engineer, operating with a complete, living, self-reinforcing system. And she was doing it without nerve gas derivatives, without killing her pollinators, and without paying a corporation for the privilege of watching her soil die. The knowledge was not lost. It was traded away, exchanged for speed and scale and the convenience of a bottle, but it never stopped working. And now you know exactly where to find it. We are here to dig up the gardening knowledge, the homesteading wisdom, and the food-growing systems that the modern industry buried and then forgot to tell you about. Subscribe so you do not miss what we uncover next. And tell us in the comments, what corner of old-time gardening or farming wisdom do you want us to investigate? Because the archive is deep, and we are only getting started.